Ever wonder how video game designers or animators create those hyper-detailed 3D characters or objects? Most AI tools today just spit out blob-like shapes, monolithic, hard to edit, and not really useful for real-world applications. But what if we could generate 3D objects as composed of distinct, editable parts, like a robot made of joints, a car with separate wheels, or a furniture set where you can swap out a chair? That's exactly what the new OmniPart framework is all about. Let's break it down. Traditional 3D generation models are like painting a whole picture without knowing where the brushstrokes go. They create shapes as a single, unbreakable form. But OmniPart takes a smarter approach. It first plans the structure of an object, then builds it part by part. Think of it like designing a house. First you sketch the blueprint where the walls, doors, and windows go, then you add the details. Here's how it works. The first step uses something called an autoregressive model, a type of AI that generates things step by step. But instead of just drawing a shape, it creates a sequence of 3D bounding boxes that represent different parts of the object. These boxes act like placeholders for things like a robot's arm or a car's hood. What makes this smart is that it uses 2D masks. Think of them as simple outlines or silhouettes to guide the process. You don't need to label every part or know their exact names. The AI figures it out based on where the masks are. Then comes the second stage, part synthesis. Here, OmniPart takes the planned structure and fills it in with high-quality details. It uses a pre-trained 3D generator, like a powerful AI that already knows how to make 3D shapes, but tweaks it to focus on individual parts. Imagine taking a rough sketch and adding textures, colors, and fine details, except this happens for every part at the same time, ensuring they all fit together seamlessly. What's revolutionary here? OmniPart doesn't just make pretty 3D models, it gives you explicit control over each part. Want to change a chair's design? Swap out the wheels on a robot. Animate a character's arm. This framework makes it possible. The researchers also solved a big problem. When parts are generated separately, they often don't fit together nicely. OmniPart fixes this with clever techniques like a part coverage loss, which ensures each part is fully contained, and a voxel discarding mechanism to clean up messy edges between parts. The results? State-of-the-art performance in creating 3D objects that are not only visually rich, but also interpretable and editable. This opens up huge possibilities for artists, game developers, and even AI researchers working on things like digital twins or robotics. So next time you see a 3D model that's easy to tweak or animate, you might be looking at OmniPart's work. It's a big step toward making 3D content creation as intuitive as drawing with a pencil, just with a lot more power under the hood. Want to see how it works in action? Check the project page link in the description. And if you're curious about how AI is reshaping creativity, hit subscribe, because the future of 3D is part aware and it's just getting started. But OmniPart is just one piece of a rapidly evolving puzzle. Let's take a quick tour of other groundbreaking AI research shaping the future of digital creation. First up, OmniPart. Think of AI image generators as artists who can mix colors, but might place a tree in the middle of a sky. OmniPart fixes that by teaching models to understand spatial relationships, like where things go in a scene. It's like giving an AI a sense of perspective, so their creations don't look off. Then there's transparent image layer diffusion. Ever tried editing a photo, but couldn't target just one part without messing up the rest? This tech is like a magic eraser for digital art. It uses latent transparency to separate objects in an image, so you can tweak a car's color without touching the background. Now let's talk 3D. Clay is like a digital sculptor that can build detailed 3D models from scratch. Imagine a robot creating a lifelike character or a futuristic city. And Michelangelo. It's AI that matches text descriptions to 3D shapes. Type a glowing alien spaceship, and boom, there it is, tailored to your vision. But AI isn't just building stuff, it's learning to understand it. Point Transformer helps models process 3D data, like scanning a room and recognizing every object in it. Meanwhile, Mesh Segmenter uses texture tricks to label parts of a 3D model automatically, like figuring out which part of a car is the wheel or the door. And here's a glimpse of the future. Deep Mesh lets AI paint 3D models like an artist, while Triplane meets Gaussian splatting turns a single photo into a detailed 3D model in seconds. These tools aren't just fancy tricks. They're empowering designers, engineers, and creators to bring ideas to life faster than ever. So next time you see AI-generated art or a stunning 3D model, remember, it's the result of researchers making machines not just create, but see the world with growing clarity. Stay curious, and we'll keep unraveling the science behind the magic.